In this part, we are going to focus on implementing the jumping mechanic to our character's movement. Unity's navigation system can generate off-mesh links or NavMesh links that allows us to jump, and by default we can go to the navigations tab, and at the bottom we can set the generated links, the drop height for example to be 5 and the jump distance to be 5, and let Unity generate those NavMesh links. To do that, we need to select our NavMesh surface component that has generated for us the NavMesh, and we are going to select the generate links to be true. And now if we bake our links, we're going to see that at some areas we may see those dark arrows that represent our generated NavMesh links, and the direction in which they are pointing allows us to jump from the start position to the end position in the direction of the arrow. But in my case, it didn't generate for me the NavMesh link here where I needed it from the base platform of our player. So in my case, I will disable the generated links and bake the NavMesh again. I will also enable the light, and we are going to now select the hierarchy and add the NavMesh links by hand by using the plus icon and selecting the AI. And here we have this NavMesh link object, which will generate us this in the scene view, this orange line representing a connection between 2 points. In the inspector, we should see that we have the start point and end point, and obviously we can define the agent type that can use those links. We want to have it as humanoid. What we want to do is go to the scene view and move the NavMesh link towards the area where we want to perform the jumping, and we want to now make sure to go to the inspector and select those start and end points and tweak those settings so that our points are on the generated NavMesh that we already have. And you can see that we have this arrow appearing, and we can see that circles on those circles on the blue NavMesh. If there is the circle, this means that the endpoint is correctly connected to the NavMesh that is already existing. Now, let's take a look which one of those is start and end point. I can see that my endpoint is where the player is, and my start point is on the other side. So I'll want to swap them, so I can see now both of the circles appearing. I may want to move my link to the center of my catwalk, and now I want to go to the inspector and make sure to swap the points so that my start point is where my player is, because we have in the inspector the setting bidirectional. If we uncheck it, we are going to see in the scene view that the arrow points only in one direction, meaning that our player can only jump from this point downwards, but not the other way around. But if you want to jump both ways, you need to set the bidirectional to be true, and now you will see the arrow pointing both ways. But with the arrow pointing one way, make sure that the start point is where you are going to be starting the jump. If you now press play and click on the other platform, you will see this awkward sliding movement, and that's not what we want to see. To fix that, we are going to define our own spline, so this curved line that will define our custom jump path. The idea is that we are going to define our own custom jump path so that if I click on the other side, our character will move according to this path, and if it is playing animation, it should look quite good. To make it all work, we are going to need a custom spline script, so make sure that you create it. Now all the scripts will be available on GitHub, the link will be in the description. What we will need to have in our custom script is a serialized field private transform, and we need to define the start, middle and end point. It will be much easier to use a game object to move them around, that's why we have this transform reference, start, middle and end. Next we are going to have a serialized field private bool show gizmos equals true, because we are going to draw the gizmo representing our spline. Now the main method that we are going to need is a private vector3 calculate position, because we need to calculate position between point 0 and 1, so lerp in between the start and end point, but since this is a spline, we're going to have a different calculation. We need to take a vector3 start position, end position, mid position, and obviously the value from 0 to 1. Next, we're going to clamp it just in case, and to interpolate on a spline, we need to first get the position between the start and middle point, which middle point represents the curve of our spline. We are going to use vector3.lerp, start, mid, and the value 0, 1. And the second thing that we need to do is lerp between the middle point and the end, again using vector3 lerp mid position, end position, and the value. And lastly, to calculate the position on the spline, we are using the lerp but between the start middle and the middle end point, and this should give us the point on our curve. Now we are going to also have some helper methods. By default, public vector3 calculate position will take only the interpolation amount from 0 to 1, and we are going to use the calculate position passing the start transform position, end transform position, and middle transform position, so the default positions that we have passed to our spline. But we are going to also have two methods, calculate position with custom start and calculate position with custom end, when we pass the vector3 start position and we use calculate position from the start position, or we calculate position with custom end when we pass the vector3 end position and pass it to our calculate position method. And this will be very useful when we want to have a very fluent movement rather than to have the player teleport to the start point of the spline. And we are going to talk about those later. For now, we have also a public void setPoints method because we want to adjust the start, mid, and end points of our spline to our NavMesh link that we have created a while ago. That's why we are going to just check if those are not null, our transforms, and next we are going to move them to the past positions. Lastly, I have this gizmo method that will draw us a gizmo. Now I'm going to just check if we are showing a gizmo and if the transforms are not null. And if this is the case, we are going to use the color red and draw 3 small spheres where our start, end, and mid positions are. And next we are going to use the magenta color and use the granularity to print a curve. And we are going to look for I equals 0 till the granularity, and we are going to calculate the position, the start position. If I equals 0, we are going to choose the start position, else we are going to use the calculate position method. And the end position, again, if the I equals granularity, we are going to get the end position, else we are going to calculate the position, and we are going to use gizmos.rowline start to end position. I don't think that this condition will ever work because this is less than granularity, so we're going to have this class. Now again, as I have mentioned, we want to connect it to our NavMesh link, so when we move our NavMesh points, we want the spline to move with it as well. That is why we will need another script called the NavMesh Link Spline. And we are going to give it an attribute execute in edit mode so that we can update our spline based on the position of our NavMesh link. So we are going to have few fields here, the spline reference underscore spline visualization and serialized field private NavMesh link underscore NavMesh link data. Those will be needed to adjust the positions of the start and end point, but I want to also control the midpoint, so we are going to have a serialized field with a minimum value of 0.01, private float height offset, this is for the midpoint of our spline, and serialized field range 0.25 to 0.75, private float placement offset, and we are limiting how far from the start and end point we want to place the midpoint, because otherwise our jump movement will look strange. So next we are going to define the update method. Again, this will be executed in the edit mode. So I want to add the preprocessor condition if, using this hashtag, if we are in the Unity editor, we are going to add this code to the script. Otherwise, we are going to discard this update method and never add it to the compiled code of our build. So in this update method, we are going to just check if we have the spline visualization and NavMesh link data, and we are going to calculate the start position by using transform the transform point, NavMesh link data start point. Now this start point and end point are in local space, that's why we are using transform point to transform the position to the world space, and we are going to get the midpoint by lerping between the start and end using the placement offset that we have used, and we are going to give it the height offset that we have defined above. And we are going to just use the spline visualization set points, the method that we have just created, passing the start, mid, and end point. And this will happen constantly in the editor when we are editing our NavMesh link. If you have both of those scripts, we need to select our NavMesh link, and we are going to use Alt-Shift-N to create a child object called Spline. And we are going to add here the Spline script. We need to have 3 more child objects, so let's create one, and we are going to use Ctrl-D to duplicate it. Let's call the first one Start. Let's call the next one Middle. And let's call the last one endpoint. And those will be empty objects, and we are going to assign them to our spline start, middle, and end. Now, if we select our start point and we start moving it, you will see in the scene view that we are painting a spline. So we are going to move the endpoint, and now we have the spline. We can move the midpoint higher, and we can see that our spline is being generated. Obviously, we do not want to set it by hand. We may want to go to the NavMesh link, the main object, and add here our custom NavMesh link spline component, and let's assign it our spline visualization and the NavMesh link, and we should immediately see that our spline was adjusted to the points of our NavMesh link. Let's give it an offset, the height offset of 2, and this is basically the jump path that should look decent enough for our use case. And you can see the midpoint is somewhere here in the middle between the start and end point, and this is what is controlling our curvature. But we still need to customize our movement so that our character uses the spline for movement. In the previous part, we have created this AgentMover script, so let's open this script up. Here, we are going to add some fields. The private bool on NavMesh link bool flag that we are going to use to know if we are on the NavMesh or not. The private float jump duration equals 0.8, which we will use for every NavMesh link to jump, the time it takes to jump between one ledge and another. And we are going to have a public Unity event on land that will trigger a sound effect, and on start jump that will trigger the animation and also play some sound effect. Next, I'm going to add the start method that turns agent auto traverse off mesh link to false, so that the NavMesh agent doesn't automatically moves through the NavMesh links. We're going to add custom code for that. In the set destination, I want to add if we are on NavMesh link, if our bool flag is true, we are going to ignore any input from the player until we land on the other side of our jump path. Lastly, in the update, after we set the speed, we are going to add 2 if statements. If our agent is on off mesh link, so if we are near the NavMesh link that we have defined and we are not jumping, we are going to call start NavMesh link movement method. And if we are on the NavMesh link, if our bool flag is true, we're going to start facing the target, because we do not only want to control the movement, but also we need to rotate our agent. So let me add the second method. Actually, outside we are going to have the face target. All it will do, it will just get the direction between the target and our player, and it will normalize it. And we are going to create a quaternion look rotation from a new vector 3 direction x, 0 and direction z. So we are going to rotate on the xz plane. And next rotation of the transform, we are going to set the quaternion slurp, so to spherical interpolation between the current transform rotation, the look rotation, and we are going to use the time delta time times 5. This will be our rotation speed. Okay, now the more difficult part is the start NavMesh link movement. So let me add this code, and we are going to start with the start NavMesh link movement. So the method that we have called in the update, we're going to set our bool flag to be true. And next, we're going to grab the NavMesh link equals agent NavMesh owner, casting it to NavMesh link. We need to do this because only this way we can get the reference to the object that is representing our NavMesh link, because we need to get the reference to our spline. So link get component in children spline. And next, we are going to call perform jump method, passing it our NavMesh link and the spline. We first need to know if we are jumping from the start position towards the end of the NavMesh link or in reverse. So that's what this bool flag will represent. We're going to call check if jumping from end to start, passing the link, because the link only knows by its default start position, not the start position from the perspective of the player. And we are going to call start coroutine move on the off mesh link, passing the spline and reverse direction bool flag. And also we are going to call on start jump to invoke the animation and to call the sound effect. First one is the check if jumping from end to start method that returns a bool flag. And here we are going to again convert the link start point and end point to the world coordinates by calling link game object transform point. This will be the start pos world and the end pos world. Next step is to calculate the distance player to start and player to end using the vector3.distance, passing the agent transform position, and the calculated above start world position and end world position. The result will be if the distance player to start is greater than the distance player to end. This means that we are jumping from the endpoint of the NavMesh link towards the start. So it is a bidirectional NavMesh link. So we return it in the perform jump, and next we need to call start coroutine move on off mesh link. And this is a coroutine because we are performing the movement using our custom code. So we have a float current time equals 0 and the vector3 cached position of the agent, the start position, so agent's transform position. And this is because we are going to start jumping from the agent position towards the other position on our NavMesh link using our spline. We're going to use the while statement, checking if the current time is less than jump duration. As you might recall, we have set it to be 0.8f in the parameters. So basically, if this is less, then we are going to add to the current time the delta time. We are going to calculate the interpolation amount equals mathf.clamp01, the current time, divided by the jump duration. And next, based on the reverse direction, we either subtract it from 1 when we are jumping from end to start, or we are going to pass the amount if we are jumping from start to end. And next, we are going to modify the engine's positions again based on the reverse direction. We are going to call our custom methods on the spline. So we are going to set the custom endpoint to the agent start position because we are jumping from this endpoint, from the player start position, towards the start point of our spline. Otherwise, we are going to jump from the start to end, and again, we are substituting the start position with the agent start position so that we do not have this teleportation that the player is teleported to the start or end point of our spline, but we have a more smooth movement of the player. And we yield return new weight for end of frame, and after this while loop completes, we need to call agent complete off mesh link to let the NavMesh agent know that it can take over moving our character. And we are going to call onLand event, so question_.invoke, so that I can play the land sound effect. And we are going to yield return a new wait for seconds 0.1 of a second, so that we do not have this situation when the player click on the other platform and the character immediately jumps. It can look a bit strange, so we give ourselves 0.1 of a second of a delay before we call our NavMesh link bool flag to be false, thus allowing our player to move our agent again using the mouse input. And basically this is it for our scripts. The last thing that we need to code is in the player script. We need to connect it, so we are going to create a movement on start jump. We are going to add listener to our Unity event this time, AgentAnimation.jump. So when we call on start jump event in our movement script, we're going to call jump animation to be played. And this is it. In the scene view, I have just assigned to the AgentMover some sound effects, and also I have set up another NavMesh link. By this time, I will set it to be bidirectional, and it will be in between the second catwalk and the second platform, and we are going to be able to jump here in 2 directions. So let's press play. And if everything was set up correctly, we should be able to perform the jump animation. And as you can see, our player is traversing those NavMesh links using our spline. And as you can see, it works in both directions if we jump. If we take a look at our scene view, you should see now that our character will be jumping using our spline. Okay, and back. And this is just traversing this path that we have set using our spline and the NavMesh link. Great! If you want to learn more about Unity game development, check out my video courses or project templates. The link will be in the description. See you in the next video.